This is an overview video of something called the Born-Haber cycle. The Born-Haber cycle deals with energy changes when an ionic compound is formed. That is, when a compound is formed by transfer of electrons. Okay, we're going to look at, I'm going to try to do three compounds. The first one is sodium chloride, the second one potassium sulfide, and the third one magnesium iodide. I'm going to write down the originating elements of these compounds. So sodium chloride would come from sodium, which exists as a solid, and from chlorine gas. I already said it exists as a gas. And I've recently shown you the video with sodium in it, so you kind of know what it is. And also, we did the lab with the chlorine. We didn't use exactly chlorine gas. We might have smelled it a little bit. We did see that it's green because I had it dissolved in water in a green liquid. Over here, we're going to use potassium. Potassium exists as a solid. You've seen sulfur in my class earlier in the year as a yellow solid. We're going to use magnesium. Magnesium exists as a solid. And then iodine exists diatomically also as a solid. All right, we're going to do the sodium chloride example first. We'll kind of talk about what has to happen for a compound to form from these two elements. So the first thing that has to happen is the sodium needs to turn from a gas, or excuse me, from a solid into a gas. So it'll be like this. And then energy is required to make that happen because gas molecules move faster than solid molecules. We have to put energy into this process. It's called bond energy. And it's oh, I misspoke. It's not called bond energy. It's called heat of sublimation. And sublimation means to change straight from solid to gas, kind of like dry ice does. You know, you probably have seen dry ice, and it doesn't melt; it just goes straight to gas. And then the chlorine has to be broken apart from Cl2 into Cls, and that is a gas. And this is also a gas. This is the bond energy that I misspoke about. So this energy is called bond energy. And it's the energy required to break the bond. All right, and I want to also mention that I'm going to divide the bond energy by 2 if I'm actually doing a calculation with this. The reason for that is there's only one chlorine atom here, but that would give us 2 chlorine atoms. We only need 1, so you have to cut that in half. All right, the next thing that has to happen is both of these atoms need to become, they're gaseous atoms, but they need to become gaseous ions. So the sodium is going to lose an electron like this. So it becomes a sodium ion, and an electron is thrown away. Okay, they're all still gases. All right, then after the electron, this electron's out here, chlorine we've recently seen likes to gain electrons. Remember the halogen lab? That the chlorine took electrons away from other things. So the Cl is going to pick up this electron. So it goes from being a Cl atom, or a gaseous Cl atom, to a gaseous Cl ion. So I'm adding the electron. Okay, yields the Cl minus ion. All right, so now we've got 2 ions floating around in the air. They have opposite charges. So what's going to happen when they have opposite charges? Those 2 things are going to attract, and you get this gaseous ion combining with this negative ion that's also gaseous, and it makes sodium chloride, which we know is table salt, and we all know that's a solid. All right, so this energy, I talked about the energy change up here. It's called heat of sublimation. This one's called bond energy. This one's called the ionization energy that we've been talking about. Ionization energy. This energy is called electron affinity, and we have not talked about that, but it is kind of like electronegativity. Electronegativity is actually not measured. It's a calculated value based on these two measured energies. And I usually don't talk about electron affinity in the general chemistry class, but sometimes I do for kids who understand the first things pretty well that we've gone through. And that's what this video is about. All right, and then the last energy change is lattice energy. A lattice is something kind of like, you may have seen a building being built, and they usually put like an iron grid work up, and then they put the walls on the grid work. That's the lattice. So lattice energy is what this is called. All right, now let's talk about signs of energy change. In chemistry, when we put energy in to something, we put a positive sign on it. So heat of sublimation, it would take energy, so that'd be a positive energy change. The bond energy is also going to be positive because energy is required to break bonds. It's kind of like you got some Tinker Toys or something, or some Legos, and you're trying to get them apart. You have to put energy into that. Okay, ionization energy is always positive. It always requires energy to remove an electron. But electron affinity is often negative. When you add an electron, energy is released. And lattice energy is always going to be really negative. A lot of energy going to be released. So you got energy in, energy in, energy in, energy out, energy out. And when you add all the energies together, you get the overall energy change for this equation. So it'd be Na plus, excuse me, I'm doing this wrong, start again. Na solid, that's the sodium that we start with at the top, remember up here, Na solid, plus Cl2, yields NaCl. Now, since there's only one Cl over here, we only need half of our Cl2s, so we do that. And that was gas, and that was solid. Right? And so, when we add all the energy changes together, we would get the overall energy change. So E, the overall energy, equals the sum of all the changes. So if you wanted to know what the lattice energy was, which is the problems that often come up, you could take all these things plus X equals this, and then find out what X was. All right, I'm going to take a quick look at K2S. Now I'm going to go maybe a little faster on this one. So you got K as a solid becoming K as a gas. And what was that called? Heat of sublimation. That would be a positive energy change. We don't have to use bond energy here because sulfur does not exist as molecules. Well, it doesn't in this case. Sometimes it does. We won't worry about that right now. Okay, then the sulfur does have to be sublimed. So you got to change from sulfur as a solid to sulfur as a gas. And that also is going to require energy, but that's also heat of sublimation. So heat of sublimation is here, and it's also here. We didn't have a heat of sublimation for the chlorine because it was already a gas. All right, the potassium has to lose an electron. The sulfur has to gain an electron. But actually the sulfur is going to gain 2 electrons because the sulfur has 6 electrons in its outer shell. So it would want to gain 2 more to get to 8. All right, and incidentally, did you notice that there are 2 Ks up here? So we would have to double the Ks everywhere we see a K. And that means that we would take this energy, the heat of sublimation, times 2. And we would take this energy, which is the ionization energy, which is energy in, also times 2. All right, the sulfur is going to gain electrons, and usually electron affinity, that's what this is called, is negative, but the sulfur in this case is going to have a positive electron affinity because it's gaining 2 electrons. You can add 1 electron and energy is released, but if you add 2 electrons, energy will be required. All right, so now we have this ion, which is a -2 ion. These are all gases. And we have this +1 ion. So the K plus, how many of those did we have? We had 2 of those, didn't we? Because we have 2 in the original compound. So 2 K pluses plus S -2 is going to yield K2S. And this is solid. That was gas. And that's gas. And that is called the lattice energy. Okay, and that's going to be hugely negative. So we have all these positive energy changes, energy being put in, but then we get energy released here, lots of it. And so when we write the overall equation, which is K, there would be 2 Ks, plus S to get K2S. If we add up all these energy changes up here, we get the overall energy change, E, sometimes called heats of formation in this case because we're forming a compound from these elements, heat of formation. So E is equal to the sum of all the other stuff. All right, now the last one, last example. If you have magnesium and iodine, magnesium is solid, iodine is a solid. We have to sublime the magnesium. So it's going to be sublimation, that's a positive energy change. We have to sublime the iodine because the iodine is a solid. Okay, that's energy, positive energy change. Energy has to, it's required, you have to put energy into that. Then the iodine that's now a gas has to be broken apart. So the I2 has to turn into 2 I's. And that is called the bond energy, and that's also positive. So that's this energy right here. Then we have to lose the electrons from the magnesium. So you're going to have magnesium is going to turn into magnesium with a +2 charge, and 2 electrons are going to be lost. And that's because magnesium has 2 valence electrons, and so it will tend to lose them both. These are all gases. I'm going to leave that off. Then a sulfur is going to gain, wait, is there sulfur? The iodine, sorry. The iodine, we have these 2 I's, are both going to gain an electron to make 2 I minuses. Now, energy is required here to remove the electron. In this case, it looks like we're adding 2 electrons, but we're really adding 1 electron per atom. And when you add 1 electron, energy will be released in almost every case. So energy is released there. And then we have these ions. We've got the magnesium ion. That's this one here. And the iodine ion. That's this one here. Being added together, you're going to get Mg(I2). And this is called, remember, lattice energy. Oops. So the lattice energy is down for here, this lattice energy. Oh man. So right here. So that's energy that's going to be out. Huge amounts of energy out. Okay, so energy in to sublime the magnesium, energy in to sublime the iodine, energy in to break the bonds, energy in to remove the electron, energy out when the ion is formed, the negative ion is formed, energy out for lattice energy. And then you add them all together and you get the sum of the energies, and that is the energy change when you have this reaction occurring. And that's where you make solid magnesium iodide from solid iodine to solid magnesium. All right, so that's a little bit of an overview. Now, in the example problems, there are actual numbers associated with all these things, but the premise is you just add up all the individual steps and get the overall energy change. All right, so that's a little bit of an overview. First time I've done that kind of video, so I hope it helped.